Hello, this is Mrs. Dowell, and I would like to teach you how to factor a sum of two cubes. The formula that is traditionally used by mathematicians is provided here. There is a very similar formula that applies to the difference of two cubes. That formula looks like this: a cubed minus b cubed factors into a minus b, a squared plus ab plus b squared. I just would like to point out to you that whatever this sign is, this one is the same, this one is the opposite, and this last one is always positive. So an acronym that is used to help folks remember the formulas or the method to factor a sum or a difference of two cubes is often referred to as SOAP. This will help you in your process. But before you can factor a sum or a difference of two cubes, you must find out if, in fact, it is a sum or a difference of two cubes. So there's a couple of things you need to look for. First, you need to make sure that this variable is a perfect cube root. Then you need to make sure that this term is a perfect cube root also. Then you want to make sure that there is either an addition sign or a subtraction sign in between them. Notice this is a binomial that is factored into a binomial and a trinomial. All right, so let's take a look at this example over here and see if we can use this formula to help us factor this sum of two cubes. At a first glance, you might say, wait a minute, that is not a sum of two cubes because 2 is not a perfect square root, nor is 250. However, anytime you are factoring, you always want to factor out the greatest common factor first. That should always be your first step. Factor the greatest common factor. In this case, it's 2. So I'm going to factor out a 2, leaving me with this, x to the third plus 125. Again, I can check my work by redistributing the 2 to make sure that it equals my original binomial. Now I can look at this binomial in the parentheses here and recognize that this is a sum of two cubes. And you may say, well, what are the two cubes? X times x times x proves that that is a perfect cube root, plus 5 times 5 times 5 proves that 125 is a perfect cubed root. So what I have is x to the third power plus 5 to the third power. Now this is beginning to take shape for my sum of two cubes formula. Notice x would be my a and b would be my 5. So I am simply going to use the formula. A, which is x, plus b, which is 5, a squared, which is x squared, minus a times b, which is 5 times x, plus b squared. B is 5, b squared would be 25. All right, now don't forget about the 2 that was originally factored out at the very beginning. I would like to show you an additional trick to help you remember how to set up a sum or a difference of two cubes by using a visual organizer. Remember, we've already factored out our greatest common factor of 2. And perhaps you will notice this is a very convenient way to remember soap. Same, opposite, always positive. I'm going to circle the first term, x plus 5. And then I'm going to circle the second term, x squared. Now I'm going to connect the two singles together, minus 5x, and then I'm going to circle the last two, plus 25. This is a plus. This is a plus. So this is the same sign. This is the opposite sign. And the last one is always positive. Let me show you how we can use this same method to help us remember the formula for a difference of two cubes. A cubed minus b cubed. That is a times a times a minus b times b times b. Circle the first ones. Same sign. Circle the second two. A squared. Multiply the two singles. A, b. Multiply the last two. B squared. Fill this in with same, opposite, always positive. I hope you found this to be useful. If so, let me know. Thank you.